This is an interesting limit. Let me do this question by two methods. The first method, well, we use L'Hopital's rule, because here obviously the numerator and the denominator both approach to 0 when x approaches to 0. Therefore, L'Hopital rules can be applied. So this means x goes to 0. And this will be 2x. That will be 1 over 1 plus x plus 2ax minus b is equal to 2. Now, then we simplify by multiply by 1 of x both top and bottom. This means the limit x goes to 0. This will be 1 plus 2ax times 1 plus x minus b times 1 plus x. And this will be 2x plus 2x squared, isn't it? Is equal to 2. Now, then we simplify, not simplify, but rather group the like terms. This 1 minus b, they are constant, and plus 2a minus b x, right? Yeah, plus 2ax and 2x plus 2x squared is equal to 2. Now, when we take limit x goes to 0, the denominator is 0. This is going to 0. This is going to be 0. This 1 minus b, if 1 minus b is not going to 0, then the whole limit will be going to infinity, not 2. Therefore, 1 minus b must be 1 or must be 0. So this means that 1 minus b must be 0. If it were not 0, then this limit would go to infinity, not 2. Therefore, b is 1. Okay. If b is 1, then this will go to 0, this will go to 0, the 0, 0. Therefore, L'Hopital rules works again. So this means the limit x goes to 0. We can use L'Hopital's rule. This is 2 plus 4x. There's 2a minus b plus 4ax is equal to 2. Okay, good. Now, when x goes to 0, this was 0, this is 0. Therefore, 2a minus b must be equal to 4. This for 2a minus b must be equal to 4. Therefore, a, because b is 1, is equal to 5 over 2. Okay, so we found the a and b. Okay, that is first method. Now the second method, Well, I hope the paper is enough room. The second method, the limit x goes to 0, 1 plus x and plus ax squared minus bx x squared equal to 2. The second method, I'm using Maclaurin series. Now, how do we expand log of 1 plus x? If you remember the formula, you can use it right away. Now, if you don't remember the Maclaurin series, it's okay. We can develop it. 1 over 1 plus x. Well, that's infinite series. You just divide 1 by 1 plus x, you get 1 minus x plus x squared, and so on. Simply do division. 1 divided by 1 plus x, you get this infinite series. Then you integrate both sides. This side it would be log of 1 plus x. That side would be x minus half x squared plus x3 over 3 minus x fourth over 4 plus, and so on. See, we have the series. Therefore, this one is a limit x goes to 0. This one is equal to x minus half x squared. Now, those terms onward, as x approaches 0, they're all zeros. And also they will not affect a and b. So we don't have to consider the remaining terms. That remaining terms all zeros. And plus ax 0 minus bx and over x squared is equal to 2. Okay. Now then, if I grouped the like terms, this is x squared, then a minus 1/2 square plus 1 minus bx is equal to 2. Okay, now look here. We know that both numerator and denominator are going to be 0. Both are going to be 0. But the ratio is 2. That means numerator is a very small number. Denominator is also a very small number. But the numerator is approached to be twice as the denominator. Okay? So that means the numerator, which is this one, plus 1 minus bx, is going to be twice as much as 2x, twice as much as x squared. Then from here, we know that a minus half is the 2. 1 minus b is equal to 0. Therefore, b is equal to 1, a equal to 5 or 2. So we get a is equal to 5 over 2, b is equal to 1. See, this method is much shorter. Okay, now we can verify by plugging a and b into the left-hand side of a given limit, and after calculation you get the limit is 2. I'll leave the verification to yourself. But anyhow, I did this limit by 2 different methods, and using Maclaurin is obviously the better way. Thank you.